Okay, fine students. In today's class, we shall discuss about destructor. In today's class, we shall discuss about destructor. Okay, fine students. In today's class, let us discuss about destructors, right? So in previous class, we have studied about constructors. So under constructors, we have studied about zero argument constructor, we have studied about parameterized constructor, and we have studied about explicit constructor, and we have studied about copy constructor. But in today's class, we are going to study about destructors. And you see the students, destructors, that is DE. Okay, here it starts with DE. Constructor means CON. It starts with CON. Only one difference, right? It starts with DE. Destructor means start with DE. Constructor start with CON. Okay. So the most important thing is here we need to understand the difference between a destructor and a constructor. That is when a destructor is called and when a constructor is called. And that's what you need to analyze. Okay. Okay, fine. So let us begin. Okay. So let me discuss each point one by one. It says that a destructor gets called, means a destructor is called for each object. Okay. For each object, a destructor is called. And when this destructor is called, a destructor is called whenever an object goes out of scope. Okay, I repeat, a destructor is called. Okay, a destructor is called when it is called. A destructor is called whenever an object goes out of scope. What it means? That is, an object goes out of scope. Okay, fine. Let me illustrate this by writing a small program. Okay, let me write. Let me write class called A. Class A. Okay. Right. Public. Inside public. And let me write a constructor. Okay. Constructor. And let me write void main. Let me try to create an object. That is for B. And let me define this constructor. Okay. Let me define this constructor. Okay. Okay, fine. What is my focus, students? My focus is towards destructor. And before that, you know that when a constructor is called, you know that when a constructor is called, when a constructor is called, a constructor is called whenever an object of a class is created. So once you create an object of a class, automatically the control goes inside the constructor and the code inside the constructor will get executed. Okay, the code inside the constructor will get executed. Is it right, students? Now our discussion is with respect to destructors. So when this destructor is going to be invoked, okay, a destructor is called whenever an object goes out of scope. What it means, okay, okay, before I reach, okay, before I reach the end of the main function, before I reach the end of the main function, the destructor is going to be called. The destructor is going to be called. Okay, the destructor is going to be called. So when a destructor is going to be called, before I reach the end of the main function. Okay, so before I reach the end of the main function, a destructor is going to be called. Right now, where this destructor is present, this destructor will be present inside the class called A. But when you see this class called A, and inside this class called A, I have a constructor. I don't have a destructor. If you don't have a destructor inside the class called A, by default, by default, your C++ compiler, by default, your C++ compiler is going to provide a default destructor. And how this destructor looks like? So this is how it looks like. This is how it looks like. You see that? So what's the difference between a constructor and a destructor? You see that a destructor will be prefixed with this tilde symbol. We call this as tilde. We call this as tilde sign. Okay, we call this as tilde sign. A destructor will be prefixed with tilde sign. Okay, so this is what default. This is how a default destructor looks like. So inside my class called A, there is no destructor. If there is no destructor, by default C++ compiler is going to define this destructor. Is it right, students? Now, when this destructor is invoked, this destructor is called, okay, before I'm sorry, this destructor is called, okay, once the object goes out of scope. When the object goes out of scope, before it reaches the end of the main function, that is here, okay, at this line. Let me change the color. Okay, yeah, at this point, okay, before I reach the end of the main function, I'm going to call this destructor. Okay, I'm going to call this destructor. And what's the job of this destructor? A destructor destroys an object. And what's a constructor? A constructor constructs an object. Okay, so before I reach the end of the main function, a destructor is called. Okay, and the most important thing is a destructor is called for each object, and that's what it says. You see that a destructor is called for each object. If I create 10 objects, for 10 objects the destructor is called, that is this default destructor is called. If I create 10 objects, for 10 objects a constructor is called, and similarly for 10 objects a destructor is called. Okay, that's what it is. That's what about destructor. Okay, so let me clear my drawings, and now let me write my own destructor. Okay, and before that, let us do some, let me write how a default destructor looks like. Okay, so this is A. What is this? This is default constructor. Okay, this is default constructor. How a destructor looks like? Destructor is prefixed with tilde symbol. It prefixed with tilde symbol and followed by A. Okay, there's only one difference. So only one difference between a constructor and destructor. A destructor will be prefixed with this tilde symbol. Okay, this is default destructor. This is how a default destructor looks like, and this is how a default constructor looks like. Okay, now let me write a destructor inside my class called A. Okay, how to write it? Just my prefix with tilde symbol, and then let me write this. Okay, let me write this, and let me define this. Okay, let me define this, and inside this, and let me write a statement: cout inside destructor. Okay? And the same, and let me write one more statement: cout inside constructor. Okay, inside constructor. Is it right, students? And let me scroll up. And, okay, let me scroll up. Yeah. Next, let me change my color. Yeah. Now let us read the second point. The second point says that a destructor appears as member function. A destructor appears as member function inside the class. A destructor appears as member function of each class. So in each class, this is what each class will have a destructor. Each class will have a destructor, and this destructor will appear as a member function, right? Each class will have a destructor, and this destructor will appear as a member function. Okay, the most important thing is this destructor will appear inside the class whether you define or whether you do not define. Whether you define or whether you do not define, this destructor will be present inside the class, right? See, right now here you see that with respect to this example, I have defined a destructor. That is, you see that here I have declared the destructor. In the destructor which I have declared, what I have done? I have defined it. Okay. Here what I have done? I have defined. Here what I have done? I have defined the destructor. Here I have defined the destructor. Okay. Let us assume that I have not defined the destructor. Let us assume I have not defined the destructor. If you don't define the destructor, by default, the C++ compiler is going to provide this default destructor, and that's what I said. Okay. If you don't define your own destructor, then by default, C++ compiler is going to provide this default destructor, and that's what it says. A destructor appears as member function for each class. Okay. Let me erase this. Okay. You see that? Yeah. You see the students, this destructor, this destructor is appearing as, member function, inside the class, okay. This is true whether you define or you do not define. If you define, it looks like this. If you don't define, then my C++ compiler is going to provide this default destructor. Is it right? And that's what the second point says. So let me erase this. Let me go point by one. Now, next, let's see. Next point. Okay. It has the same name as that of the class. Okay. A destructor will have the same name. A destructor will have the same name as that of the class. Right? Is it true, students? What is the name of the destructor? That is A. And what is the name of the class? That is A. And that's what it says. A destructor will have the same name of a class. But only one thing is, a destructor is prefixed. It prefixed with tilde sign. You see that? It has prefixed with tilde sign. And that's what it says. Okay. Now let us move to the next point. So let me clear this. Now let us move to the next point. Okay. Let's move to the next point. The next point says that it does not return anything. In other words, a destructor does not return anything. You see that here, there is no return type. So there's no return type for destructor. This is true for constructors also. You see that constructor also does not have any return type. So not even void. Okay, not even void. It means that a destructor will not return, not even void also. That's what it says. Okay. Okay. Now, let me clear this. Now, the most important difference between a constructor and destructor is a constructor can take arguments. A constructor can take arguments or parameters, but a destructor does not take. It's a very, very important difference. A destructor does not take parameters, whereas a constructor can take parameters. For example, I can write a constructor something like this: a int a int a. Okay, a int a. I can do it. Okay. So what is this? What is this, students? You see that my constructor is taking a parameter. My constructor is taking a parameter. Okay. But if the same thing, if I made this constructor as destructor, by prefixing with tilde symbol, then my destructor cannot take any parameters, and that's what it says. You see that it says a destructor does not take any parameters. Okay, a destructor can never take any parameters. So it's very, very important difference between a constructor and a destructor. So if you write a destructor something like this: int a, int a. Okay, this is wrong. This is wrong. This isn't wrong. This is wrong. Why it is wrong? Because inside because inside your inside your destructor you have passed a parameter which is not true. So that's why this is not at all a destructor. Okay. So this is the most important difference between a constructor and a destructor. Okay. Fine. Oh, let me clear my drawings. Clear. Yeah. Fine. Yeah. Fine. Fine. Okay. Fine. One more thing. Let me clear this. Yeah, fine. Okay. So let me discuss the next point. Okay. What's the prototype? Prototype is nothing but the syntax of a sorry students, 1 second. What's the syntax of a destructor? The syntax of a destructor is something like this. It begins with tilde symbol. Okay, it begins with tilde symbol. As you see that, here also you see that I'm beginning with tilde symbol, followed by the class name. And what's the class name? That is A. A is a class name. You see that A is a class name, followed by this parenthesis. In a similar fashion I've done, followed by parenthesis. This is what a prototype of a destructor. This is what the prototype of a destructor. Okay, okay, fine. So let me clear all my drawings. Let me clear all my drawings here. Now, let us see. Now in this program, okay, in this program, I have written a destructor. Okay, I have written a destructor. Where I have written a destructor, I have declared a destructor. I have declared a destructor. The destructor which I have declared, I have defined it. The destructor which I have declared, what I have done, I have defined it outside of a class. Now the question comes, when this destructor is going to be invoked? When this destructor is going to be invoked? Okay. Okay. So when this destructor is going to be called, students, I think I have discussed, and let me do it again. Okay. So now, as I said, okay, when this destructor is going to be invoked, okay, before I reach the end of the main function, that is above this closing for this. Okay, so before I reach the end of the main function, I'm going to call this destructor. I'm going to call this destructor. So once I call this destructor, the code inside the destructor will get executed. And what's the code inside this destructor? That is cout inside destructor. So it will be printing inside destructor. And before that, students, as you know that once I create an object of a class, what's going to happen? When I create an object of a class, the control jumps inside the constructor. The control jump inside the constructor, and the code inside the constructor will get executed. Okay. So how many objects I've created? I've created only one object. I've created only one object. Since I've created only one object, okay, the code inside the constructor will be executed only once. So I'll get the output as inside constructor. Okay, I'm not writing full name, just I'm writing short. Okay. So next, what I'll be doing? So next, I'll be reaching the end of the main function. Okay. So what I said, before I reach the end of the main function, I'm going to invoke this destructor. So when I'm trying to invoke this destructor, and the code inside the destructor will be executed. And what's the code inside the destructor? That is inside destructor. I'm going to print inside destructor. It's quite simple. Okay. Okay. I hope you understood this. Let me clear my drawings. Okay. And let me write a small program. You can guess the output of this program. Okay. Let me create two objects, ob1, comma, ob. Okay. And let me write cout inside main function. Inside main function. Okay. Now, can you guess the output of this program, students? Yeah, you can easily do it. So what's the output? Yeah. Okay. So let me discuss. How many objects I've created, student? I've created one. This is my first object. And what is this OB2? This is my second object. Okay. Now, so whenever I repeat, whenever I create an object of a class, okay, the control jumps inside the constructor. Whenever I create an object of a class, the control jumps inside the constructor. How many objects I've created? I've created two objects. Since I've created two objects, two times this block of code will be executed. So since this block of code is executed two times, that is for each object OB1, OB2, I'll get the following output. So it will print inside constructor, inside constructor. And again it prints inside constructor. The first time it prints for object OB1. So first time it prints for object OB1, and second time it prints for object OB2. Okay, OB2. Okay, next. So next, so after executing this statement, I'll be executing the next statement, that is cout inside main. So that's why I'll be printing here. So I'll be printing, the next is inside, inside, inside main function. I'll be printing inside main function, printing inside main function. Okay, I'll be printing inside main function. And next you see that I'm reaching the end of my main function. What I said, before I reach the end of the main function, I'm going to invoke the destructor. I'm going to invoke destructor. Now the question comes, how many times this destructor is invoked? It depends upon the number of objects I've created. So with respect to this example, we can easily see that I've created two objects. I've created two objects. So since I've created two objects, so two times the destructor is going to be invoked. That is for each object. That is for OB1 and OB2, this destructor is going to be invoked. So what I'll get in the output? The output I'll get inside, inside destructor, inside destructor, inside destructor. And this for OB1. And next, again, I'll get inside destructor, inside destructor. This for OB2. Okay. Yeah, actually, there's a problem with internet connection. It went up and down. Okay, it's going up and down. But anyhow, so let me write the output what we have seen just now. Okay, I said, uh, inside. It will print first. It will print inside constructor. It will print inside constructor. Okay, it prints inside constructor for object one. Again, it prints inside inside constructor for B2. Okay, and next it prints inside main function. It's main function. Okay, prints main function, and next it prints inside destructor, inside destructor for OB1. And next the same thing again, it will print inside inside destructor for OB2. As you notice, students, okay, the number of times constructor called, is equal to the number of times destructor called. The number of times constructor called is 2, and the number of times destructor called is 2. This is true. Okay. Why? Because for each object, you are going to call destructor, and similarly for each object you are going to call constructor, and similarly for each object you are going to call destructor. Okay. So the number of times you are going to call constructor is same as the number of times you are going to call destructor. Right? I hope you understood the concept of destructor. Okay. Now let us see when we should write our own destructor. Now let us see when we should write our own destructor. Okay. So let me clear my drawings. See, probably you can recollect in the previous class I've created an object called S1. In previous class, I've created an object called S1, and inside this object, I'm having a variable called LEN, okay? And I'm having a pointer variable called CSTR. And this pointer variable will be pointing to a dynamically allocated memory. And how this memory is allocated dynamically? It is allocated by executing the following statement, that is new char len plus 1. Again, that's what you have written in the previous class. With respect to copy constructor, we have done. Okay, using this statement, that is new char len plus 1, using this, what we have done, dynamically we have created an array. Okay, so what you mean by dynamically created? See, it is something like this. Okay. See, once you write the program, what you'll be doing, you'll be compiling the code. Once you write, you're going to compile. So once you compile, you're going to run the program. So during compilation time, when you try to allocate any memory, during compilation time, if any memory allocation is taking place, because that memory allocation will take place inside your stack memory. Okay. Any memory, I repeat, any memory that is allocated during compilation time, it gets allocated inside your stack memory. And probably this you will be studying inside in your operating system subject. Anyhow, I'll give just an idea about this. Okay. Any memory that is allocated during runtime, it gets allocated inside your heap memory. Okay. I repeat, any memory that is allocated during compilation time, that is once you write your code, what you'll do, you're going to compile the code. So once you compile the code, okay, the memory is going to be allocated. Where the memory is going to be allocated? The memory is going to be allocated in stack memory. Okay. So during compilation time, okay, if any memory is allocated, this memory is allocated in stack memory. During runtime also, so once you compile, you need to run the program. So when you run the program also, some memory needs to be allocated, or some memory may be allocated. And this runtime memory will be allocated in heap memory. Okay. You see that here, students, here I've written a keyword called new. The keyword new says that I'm allocating memory during runtime. The keyword new says that I'm allocating memory during runtime. So any memory that is allocated during runtime, we call this as dynamic memory allocation. So any dynamic memory allocation will take place inside your heap memory. In other words, the memory allocated for this array, will be allocated inside your heap memory. Okay. The memory allocated for this object S1, will be allocated inside your stack memory. Okay. Now what is the job of a default constructor? Okay. Before I reach the end of my main function, what's going to happen? The memory allocated for this object is going to be destroyed. Okay. The memory allocated for this object is going to be destroyed. Now once the memory allocated for this object is destroyed, then what about this memory? This memory is still present. Inside my heap memory. That is not correct. Yes. Why this is not correct? Because S1 is using this memory. Now S1 itself is destroyed. If S1 is destroyed, who's going to use this memory? No one. If no one are using this memory, then this memory will be waste. This memory is waste. So what I should do, before I destroy this object, the memory allocated for this object needs to be reclaimed. Okay. Reclaim means the memory which I have allocated, I need to take it back. Okay. I have allocated some memory inside my heap. Okay. Now since I'm going to destroy this object called S1, okay, the memory which I allocated, I need to take it back. How I can do it? I can do it by writing my own destructor. That is, you declare a destructor inside the class and then you try to define it. So once you define, instead of writing like this, what I should do, okay, I need to reclaim the dynamically allocated memory. How I can do it? I can write a statement something like this, that is delete. I can write a statement like this, delete CSTR. Okay. Once I write a statement something like this, delete CSTR, okay, so the dynamically allocated memory is going to be reclaimed. Okay, the memory that I've allocated dynamically, it's going to be reclaimed. Okay, once I reclaim the dynamically allocated memory, then I'm going to destroy this object. That's why we need to use your, that's why we need to write our own destructor. So there may be cases where we need to write our own destructor. So this is the case. This is the case where we need to write our own destructor. Hope you understood this, right? So let me erase this and let me write this. Write this. Let me write this. Let me erase and let me write here. Delete CSTR. Something like this. This is a statement. Once you write this statement, okay. So once I write statement, something delete CSTR. What's going to happen? The memory that has been allocated dynamically, it's going to be reclaimed. Okay. So once I reclaim the memory, next what I'm trying to do? Next I'm going to destroy this object. I hope you understood this. Any questions, students? If there are no questions, and that's all for today's class. Have a nice day. Yeah.